What's the best solution for a home network? Is it Wi-Fi? This is a Wi-Fi 7 access point. Is it MoCA or multimedia over coax cable? Is it PowerLine perhaps? What about traditional Ethernet? So as an example, copper Ethernet. Or perhaps it's fiber, multi-mode, single mode fiber. What's the best solution? Now, there are many types of criteria that you could use. In this video, I'm going to test the speeds of these various solutions. So as an example, this goCoax solution versus PowerLine versus Wi-Fi versus Ethernet. So what gives you the best performance? And what about security? So I want to discuss security as well. So as an example, the issue with Wi-Fi is someone could be outside your home or business and could crack a Wi-Fi network if it's not configured properly. It's easier to crack a Wi-Fi network versus fiber. It's much harder to tap into a fiber network versus a Wi-Fi network. So fiber is definitely a lot better when compared to Wi-Fi from a security point of view. But let's put this to the test practically. The sponsor of this video is Brilliant, and they are literally brilliant. Brilliant is an interactive learning platform that helps you get smarter every day with courses in mathematics, science, programming, data analysis, AI, and more. Their lessons are hands-on and based on problem solving, not passive watching. And this is the reason I really like them. And this is the reason that my team really like Brilliant. You are involved in your training. You're not just passively watching someone drone on and on. You are involved in learning new concepts. This approach helps you truly understand the material, whether you're revisiting foundational concepts or learning something entirely new. I personally like this and my team like this because it's designed to make learning more effective. Each lesson is broken up into clear interactive steps that help you build a deep understanding, not just gaining surface knowledge. And you get quizzed on your knowledge. So you learn something, and then you have to answer questions about what you've just learned. Very interactive, a very good approach to learning. They also add new content on a regular basis, so it makes it easy for you to build a consistent daily habit of learning, even if you only have a few minutes to spare. Now, if you're interested in networking, cybersecurity, or automation, or even AI, I would recommend that you look at the following courses: Thinking in Code, Logic, or How AI Works. These courses are especially useful if you're working with Python or trying to improve how you approach problem solving in real-world IT scenarios. You can try everything Brilliant has to offer for free by visiting brilliant.org/David Bombal. You'll also get 20% off an annual premium subscription if you decide to continue. That's brilliant.org/David Bombal. Link is in the video description. I really want to thank Brilliant once again for sponsoring this video and supporting my channel. Let's start with PowerLine. Now you may have to use PowerLine in your network if a part of your home, as an example, can't be reached easily via Wi-Fi. So this gives you an easy solution using the existing power cables in your home to create an Ethernet network. These are TP-Link PowerLine devices, supposedly support up to 2 gigabits per second. So 2000 megabits per second. So they claim. But let's see what you actually get. So here I've got a multi-plug, and I'll connect these two to the multi-plug. Now, in a lot of the documentation, they'll tell you that you shouldn't use a multi-plug. These should be connected directly into your wall socket. But this will allow me to test the speed with 2 power lines connected very close to each other. In the real world, your speed may be a lot lower than what I'm demonstrating here. So for this demonstration, I've got 2 MacBooks. They're connected to 10 gig Ethernet adapters. So they should, in theory, be able to send traffic at 10 gigabits per second. At the moment, they're connected via Ethernet. So just to prove that to you, I'll start iPerth with the Ethernet adapter. But just to show you the network setup, this MacBook has an IP address of 192.168.1.1. This MacBook has an IP address of 192.168.1.2. So very easy. I'll start iPerth on the Mac at the top, and I'll connect to that using this MacBook. And I'm getting those speeds, 9.88 gigabits per second. We're getting almost 9.9 gigabits per second. So copper Ethernet works really well. So what I'll do now is connect the Ethernet cable to the PowerLine adapter. And what you'll notice now is the line has gone to 0. There's no throughput at the moment because we're obviously not connected. So what I'll do is connect the other side. So connect the Ethernet cable to this PowerLine adapter. And let's see what speed we get. To make sure that we get proper figures, I'll stop this and then start it again. And what you'll notice there is we're getting about 350 something megabits per second. So we're not getting anywhere near 2 gigabits per second using PowerLine adapters. Now in a real world test, this will be even lower. Here we're only getting 363 megabits per second, nowhere near the advertised 2 gigabits per second. Now PowerLine I will rate as D tier. This is not so good. Performance nowhere near the advertised rate of 2 gigabits per second. Also in real world environments, you can get interference. Someone turns on a washing machine as an example, or another appliance could affect your internet speeds. But if there's no other option, at least this gives you an internet connection. There are caveats, however. You need to be on the same circuit breaker, but it is a very easy option to use because homes come with power. Yours may look very different to this. This is a UK plug, so obviously the outlet will be different depending on where you are in the world, but this can simply be plugged into a wall socket, giving you internet access. Now, from a security point of view, better security than perhaps Wi-Fi, because someone would have to physically tap into your power cables, and you can have encryption enabled on these devices. So if someone did manage to connect to a wall socket and listen to the traffic would be encrypted. What do you think? Do you agree with that assessment, or do you really like PowerLine devices? Now, the next option is to use coax cable in your home. Your home may have cable television and coax cable connections throughout your home. So this gives you another option where you can run Ethernet directly across coax using an adapter like this. This is a goCoax adapter. What it has on the one side is Ethernet, power, and then coax cable connector on the other side. So all I need to do is connect the adapter to the coax cable, and obviously do that for both connections. Now you can use splitters to connect more than 2 devices, and the splitter can be used so that there's no interference between your television and your Ethernet connection. So what I'll do here is connect the one adapter and the second adapter. So I've now got both adapters connected via Ethernet as well as coax. So both laptops are connected. I need to power these on, and what you'll hopefully notice there is they are connected, and in my example I've enabled security. These devices don't have security by default, but you can enable security on them. So as an example, if you're living in an apartment complex, you can have this encrypted so that other people can't see what you're sending. Okay, so I'll start iPerf again. And what you will see there is we're getting 1.79 gigabits per second. Now we're getting about 2.1 gigabits per second. So much better than PowerLine. The speeds on this were terrible compared to using coax cable. So if you've got coax cabling in your home or apartment, this is a great solution because, again, you don't have to drill, you don't have to lay Ethernet cables, but you're getting very good speeds. In theory, 2.5 gigabits per second. As you can see here, I'm getting about 2.1 gigabits per second. In practical tests, I've found that I get very high speeds. So I've only got a gigabit internet connection here, and I easily get that with these adapters. Again, it will depend on the cabling in the building, how old it is, how good quality it is, but you can have multiple adapters once again. So it's not point to point like you would have with Ethernet, but obviously the more that you connect, the more it'll affect your throughput. But I'm very happy with that, 2.23 gigabits per second. Advertised speed again, 2.5, very, very good, much better than PowerLine, and probably will be much better than Wi-Fi. Now on the tier list, I would say that this is ranked B. High throughput, over 2 gigabits per second. You can enable encryption on these devices, so better security. Also harder for hackers to break in because, I mean, they have to have access to your coax cable. If you're at home, in an apartment, it's going to be much easier for them to get access to the data. But again, it can be encrypted, which makes it much harder. So great solution this if you've got coax cabling in your home or your apartment. It's also much less susceptible to interference when compared to PowerLine devices. These are very susceptible to interference. This is a much better solution. Do you agree with that assessment? Do you like these devices or don't you? Okay, so now let's test Wi-Fi. This is a Unify Wi-Fi 7 access point. I really like Unify, fantastic for home and business environments. What's the throughput on a Wi-Fi 7 access point, however? So in this example, I've got 2 iPhones. This is an iPhone 16, iPhone 15. I will set the 16 to server mode, and then I'll start the connection on the iPhone 15. And what you can see there, we are getting 450 megabits per second. So about 450 megabits per second between these two phones. Going down a little bit, the access point that I'm connecting to is right over there. It's probably about a meter away from me. Speeds vary, but let's say around 450 megabits per second throughput between these two phones. Obviously, a huge advantage of Wi-Fi is you don't have to be hardwired into a network. You can use mobile devices. Now, from a security point of view, you should enable WPA3 whenever possible. So much better than WPA2. A lot of Wi-Fi attacks don't work with WPA3, so use WPA3 wherever possible. The issue, however, is a lot of older devices don't support WPA3. So best practice is to use separate SSIDs or Wi-Fi names. Put your more secure devices on WPA3 in a separate network, separate VLAN. Less secure devices perhaps using WPA2 in a separate VLAN, separate Wi-Fi network. So important devices like your phone, put on a VLAN that supports WPA3. Less secure devices such as IoT devices, put on WPA2 if you have to, if they don't support WPA3, and put them in a separate VLAN. Don't put your IoT devices on the same network as your important devices such as your phones or your laptops, etc. Now what I'll do is test using the iPhone 16 to this laptop. IP address on this laptop is 192.168.1.246, and that's what I've got here. So I'll press start, and as you can see there, we're getting 445 megabits per second, 430 megabits per second from this phone to this laptop, 450 megabits per second. Again, the Wi-Fi access point is about a meter away from these two devices. Your Wi-Fi network speeds will vary a lot. Depends on the devices, depends how far away they are from the access point, depends on a lot of factors. Interference, what's supported on the phones, etc. This, I would say, is not the best example of speeds. You may get much higher speeds in other tests. Some people get 1 gigabits per second as an example using a Wi-Fi 7 access point from their phones, but this is much better than, say, PowerLine. Probably for a lot of us, not as good as the speeds that you would get with a coax cable. But the obvious advantage of Wi-Fi is you can move around. You don't have to be physically hardwired to a network. Most devices like iPhones, etc., aren't going to be used with a physical cable. Now here's a real world example. I'm connecting to the internet, going to fast.com, so the Netflix site. So as you can see here, I'm getting like 580 megabits per second, 600 megabits per second. It's settled on 570 megabits per second. Now you may be able to get much better speeds than this, but that's a real world example using Wi-Fi connected to the internet. So I'll run that again, 160 megabits up speed. So here again, we're getting 520 megabits per second down, about 190 megabits per second up. This will depend on your internet connection and your Wi-Fi. You could optimize your Wi-Fi to be a lot better than this. So you might be able to get 1 gigabits per second or 1.5 gigabits per second. But I personally don't like using Wi-Fi unless I have to. From a security point of view, I prefer using Ethernet. So either copper or fiber. Much lower latency, much higher speeds. Lots of advantages to Wi-Fi, but from a speed and security point of view, I would put it at C tier, maybe B tier, but I will go for C tier in this example. Don't know if you agree. Probably a lot of people are going to say me hate about this. They're going to say my Wi-Fi implementation is really bad. You can get much higher speeds, but in most cases, you're not going to get the speeds like you would with coax cable or Ethernet. So let's go with C tier. Let me know in the comments below what you think. Where would you put Wi-Fi? Do you think this is the best solution, better than cables as an example? Now, Ethernet is my favorite way to connect to a network. You get much higher speeds, and it's more difficult for hackers to attack you if you're using wired connections rather than Wi-Fi. Here's an example of a Cat7 cable. Here's an example of Cat5e. These two MacBooks are now connected using Cat6a. So let's run a speed test again. So I perf between the two of them. As you can see here, we're getting 9.8 gigabits per second, 9.85 gigabits per second. So these network adapters are limited to 10 gigabits per second, and I'm getting very close to that using Ethernet. Now, according to the standards, Cat5 supports 100 megabits per second. Maximum transmission distance is 100 meters. Cat5e is 1 gigabits per second. Cat6, 10 gigabits per second. 6a, 10 gigabits per second. Cat7, 10 gigabits per second, Cat 8, 25 or 40 gigabits per second. This is from fs.com. So you can get much higher speeds using copper Ethernet. The ultimate solution is to use fiber. In this example, I've got two computers with 25 gig and 100 gig Ethernet cards in them. This is an example of the 25 gig card. You can take two SFPs. So as an example, you could insert a copper SFP, but we're going to focus on fiber. This is a 10 gig fiber SFP, but you may prefer just to use copper in that case. So what I've got here is a 25 gig fiber SFP, and that's actually what I've got in the computers. This is using multi-mode fiber, but you also have the option to use single mode fiber. This has a maximum distance of 100 meters, but the single mode fiber has a maximum distance of 10 kilometers. So your Ethernet connections can really be long distance. Single mode fiber can go a lot further. So as an example, 10 kilometers using this fiber SFP. So I could put single mode fiber into the network card, 25 gigabits per second, 10 kilometers, or multi-mode fiber, so 25 gig multi-mode fiber, 100 meters. This gives me two connections running at 25 gigabits per second in a single network card. That's what I've got installed in this computer and one below my desk. It only has a single SFP installed, multi-mode fiber, 25 gigabits per second. So what I can do is remove these covers, and then I can insert this in the computer. So what I'll do is insert it. As you can see there, the link light came on. So now I'll be able to test speeds on this computer. So what I've done is connect both computers to a KVM switch. That'll allow me to switch between the two of them. So this is computer 1. This is computer 2. So on this computer, on my desk, if I go to control panel, network and internet, network and sharing center, and look at my adapters, this adapter, Ethernet 7, is connected at 25 gigabits per second. This device has an IP address of 192.168.1.201. The other computer has an IP address of 192.168.1.200. So on this computer, which I'm going to set up as the server, I have iperf downloaded. So if I open up a command prompt in that directory and type dir, I've got iperf here. So I'll type iperf, press enter, and we can see the option S for server. So I'll set up this device, which has IP address 192.168.1.200 as the server. Okay, so iperf S, server is running. So I'll jump back to the computer on my desk here. Again, I have iperf downloaded, so I'll open up a command prompt in that directory. dir in this directory shows us that we've got iperf here. So I'll type iperf client, and we're going to connect to 192.168.1.200. So this computer connecting to the one below my desk, it's now connected, and you can see that we have a connection speed of 23 gigabits per second. So in my tests, this varies, but generally I get over 23 gigabits per second between these two computers. So they're 23.7 gigabits per second. That's a lot better. So 23.7 gigabits per second between these two computers using a 25 gig Ethernet port and a fiber connection. So we're using multi-mode fiber here between the two devices. We are getting 23.7 gigabits per second. I don't know if you agree, but I think that's really good speeds. That's the kind of speed that we want to have in our network. Okay, so copper Ethernet, I'll put at A tier, much better than the other implementations. If you can use copper Ethernet, then do that. But there is something better than copper, and that's fiber. From a security point of view and speeds point of view, fiber is better than copper. But in this example, I'll put copper at A tier and fiber at S tier. Fiber is just so much better from a security point of view, much harder to tap into fiber. Copper Ethernet is easier, but not as easy as Wi-Fi to attack. Wi-Fi, you could be outside in the parking lot and attacking it. With fiber and copper, you've got to tap into the cable. Much harder with fiber to tap into the cable. So that's an example with 25 gigabits per second in a computer. Now you can go higher than that. Here's an example of a QSFP28 100 gig Ethernet. So in these two computers, I also have 100 gig Ethernet cards. So with these kinds of connections, you could get 100 gig Ethernet at home. That would be a lot of overkill, but I've demonstrated this for quite a while now already. 100 gig Ethernet using fiber is going to be a lot better than even 1 gig Wi-Fi. So in this example, I've got a 100 gig QSFP28, and here I've got a fiber cable with MPO connectors. So I can take the cover off, and I'd be able to insert that into the fiber cable as follows. So this gives us 100 gig Ethernet, but the computers that I'm using are not that powerful. So let's see what kind of speed we actually get. In theory, 100 gigabits per second, but we may not get that because these PCs are a little bit old, don't have the capability to send and receive at those kind of speeds. So I'll insert the QSFP28 into the computer. I'll now connect the fiber cable. Okay, so there you go. I've got a 100 gig connection on both these computers, one on my desk and one below my desk. So in control panel, you can see Ethernet 4 running at 100 gigabits per second. This interface has an IP address of 192.168.2.200. So again, here I'll run iperf. So iperf server. Server is now running. I'll go to the client computer. As you can see on the client computer, Ethernet 3, 100 gigabits per second. This device has an IP address of 192.168.2.201. So what I'll do is run iperf client 192.168.2.200. So connect to the server. Now, this is terrible speeds. We should be getting much greater speeds than this. And the problem here is probably because I'm running recording software. So what I'll do is clear the screen and turn off the recording software. And let's see if that improves things. So hopefully you can see that on the camera. I'm going to run that again. That's better. We're getting like 48 gigabits per second, 49 gigabits per second. So hopefully you can see that we're getting 47.3 gigabits per second. So you can see 48, 49 gigabits per second, much faster. And that's because I turned off my recording software. I'll run this again. 44 gigabits per second, 46 now, 47, that's better. So 45, I would have hoped that it'd be a lot higher than that, but these computers are not the very best. They are limited in what they can send and receive. So we're getting about 48 gigabits per second, 48.4 gigabits per second there. I think that proves the point that with a fiber cable, you can send at very high speeds. The limitation here is not the network card or the speed of the network, it's the speed of the computers. I've used these computers in previous tests, got higher speeds, had to try and really optimize them to get higher, but the limitation is on the computers themselves, not on the network. Another option is to use DAC cables like these. They give you very high speeds, but only for a short distance. So here I've got a 100 gigabits per second direct attached copper cable, or some people commonly refer to it as a DAC cable, which I'll use to connect to the computers. So we'll pull out the fiber cable and replace it with the DAC cable. So I'll take out the fiber, take out the QSFP28. Okay, so I have replaced the fiber cable with the DAC cable. So network is showing as connected, and I'll run iperf again. Again, because of the software affecting the speed, I'll just record it this way. But notice there we're getting 41 gigabits per second, 48 gigabits per second, 47.8 gigabits per second here. So those are the kind of speeds that you can get. In this example was two older gaming computers with 100 gigabits per second network cards with fiber or DAC cables. So I would put DAC cables at either S tier or A tier, depends on what you decide to do. But let's put them at A tier. Best is fiber, long distance, very difficult to break into high-speed connections. But there are problems, obviously, with using Ethernet. You have to install this, and you may not have it in your building. But if you can install fiber, it is harder to work with, much more difficult than copper Ethernet. So these would be my two choices, either copper Ethernet or fiber. If you can, fiber. Now, in a lot of cases, you'll make a different decision based on what's available in your building. Now, this is not going to help you if you don't have cable television or coax in your building. This may be your only solution, or you may just prefer to use Wi-Fi because of the advantages of Wi-Fi. But personally, fiber is my ultimate, and then it would be copper Ethernet. And I'm assuming a lot of people are going to complain about me using straight copper like this, but in some cases, this is much easier to install. but it's your choice. Let me know in the comments. Hopefully there won't be too many angry comments or hate comments based on what I've shared here. Let me know what you think.